Okay, here we are with the Unit 5 practice test answer key. I wrote it out once and then made a mistake. The camera ran out of me, so I'm already have written some of this in. For the first one, in fact all of these, it's all about vertical line test. If you pass the vertical line test, it is a function, so that is. Then you're supposed to give the domain and range. The domain are your allowed x values, and they're trapped between -5 and +6. You can say it's a member of all real numbers. Try to put that somewhere. The y values then are trapped between 0 and 4, so they're not going to be found above or less than that. In this one, again, it passes vertical line. Gaps right there are okay. You just don't want ever to have a dot over a dot, because then that would be appearing twice. So in this case, the domain is from -6 to +1, and from +4 it looks like up to +7. And notice that that's an open, and notice that that is not equal to, but up to 7. And then the range is the -4, -2, and +2. Those three values are the only possible outputs. Okay, when you list ordered pairs, you want to just make sure that if you plotted them on a graph, you'd have dots that would pass the vertical line test. They do. The domain is 1, 2, 3, 4, and 5. Those are the only allowed inputs that I have. The outputs are trapped only with 4s and 3s, so that's the outputs. The second one is not a function because it fails the vertical line test. You have two different outputs given that same input number 4. So now the question is whether these things are polynomials or not. This first one is definitely a polynomial. It's okay to have a radical as far as a number out in front. That's just the constant term. These exponents must be whole numbers. In this case, it's a 0. X to the 0 is just 1, and the coefficient there is 10. So I put it in descending order. The degree is 5, and the lead coefficient is that first number there. It's -7. I forgot to give you a spot to write that. The second one is not, because you can't have a square root of an odd degree exponent. If it was an even degree, you could take the square root and it would be half that value. So the square root of x to the 4th would be x squared, but I'm not going to try to trip you up that way, but that's odd and it definitely does not work. These are rational functions when they're not reducible to a polynomial, but yet each one is a polynomial. In this case, they are both polynomials. You can't factor and cancel, but you can find the vertical asymptotes by factoring the bottom, and you've got two of them at -5 and at +3. The horizontal asymptote, when you compare the degrees, that's larger, so it wins over the denominator. So infinity over 1 is going to go towards infinity, which is what that is right there. Then the second one is also a polynomial all over a polynomial, but when you ask yourself when will x squared be equal to -15, you can't take the square root of a negative, so the answer is that there are no vertical asymptotes. The horizontal asymptote is the lead coefficient of the two equally degreed highest terms, so 2 over a little invisible 1 is 2 over 1, which is 2. All right, that's first page. Second page, this first thing is a quadratic, so we spent some time graphing those. These are the 5 points of a parabola. When it's a second degree polynomial, it's a quadratic. So the first thing you want to do is find the vertex. This is the axis of symmetry. Axis of symmetry, and that's your x coordinate right there. And then you take that x value, 2.5, and we plug it into our minus b over 2a formula. You plug in 2.5 and you square it, you get 6.25. You multiply it by 5 and you get 12.5. And you combine those and you get -6.25, and then minus 14 gives you -20.25. So here's your all-important vertex right there, and I guess you could label them on this. It's as easy as anything, vertex. Then this is the y-intercept. This is your symmetric point, and these are your x-intercepts, your zeros. You call them zeros because that's the value for x. When you plug it in, gives you a 0 output. And you find that by factoring and setting each one of these equal to 0, hence the name 0. That only happens when x is +7, and you only get a 0 there when it's -2. We find the symmetric point by taking however far it is to your axis of symmetry, and then doubling that and going away from this y-intercept. Keep that negative value or positive value, the y value, keep that the same. Okay, this next one is a rational function. Try to factor it if you can. If it's a quadratic, you can plug it into your calculator. You're going to get positive 2 and positive 2. That will tell you that it factors to be x minus 2 and x minus 2. This one you can take out the x, and you're going to get x squared minus 4, and then that factors to be x plus 2, x minus 2. The x minus 2's cancel, and so you wind up with this is what the function really is. It is still a rational function, but you only get zeros when x is 0 and when x is negative 2. So you need vertical asymptotes at 0. You can write on there x equals 0 and x equals negative 2. And then put it into your calculator and see what it looks like. Is it going to go like this or like that? So turn that on, and I did graph it. I typed it in, and hopefully it's minus 2 over plus 2. Yep, parentheses are all good. And look at the graph then. And so it looks like it goes, it's this lower one, so I'll make that darker. And then it does a U-shaped thing here. Now it's useful to know how low it goes. And then it looks like it's going like this. The horizontal asymptote is 0 because when you compare the degrees, the degree is larger in the denominator, so it becomes 1 over infinity, which goes to 0. So for the horizontal asymptote, you get it at 0. The vertical asymptotes, it's worth labeling those at 0 and negative 2. Okay? Where is that lowest point? If I gave you an extra credit about the domain and range, the domain, x is a member of all real numbers, but x cannot be negative 2 or 0. The range value, it looks like the f of x's can be all real numbers except that it's going to be trapped, well, I should say it's going to be greater than whatever that value is. And I don't want to spend too much time on it, but if I do second calc and look for the minimum, that's number 3. And then if I jump over to this side of the graph here, you'll see I'm going to be on the left-hand boundary of my minimum, and then I'm going to go over and be slightly on the right-hand side. There, I can see it there. See that it's hard to see the 2 pinchers, but when I hit it enter again, it's going to tell me the minimum is at 2.914. Well, that's some crazy radical which we could solve for, but we're not going to now because it would just be extra credit. But you'd say that f of x is going to be greater than or equal to 2.914, and then f of x is going to be less than but not equal to 0. So that would be extra credit only. So don't stress out if that doesn't make sense. This last one is a simple polynomial. We want to graph it and have a sensible window here to show it. We want to factor it as much as we can. We take out an x. We then get x times x squared minus 49. That goes plus and minus 7. And x minus 7. Just remember that I get the 0 here at negative 7 because it's when this is equal to 0. We don't get it from looking at this and saying negative 7. We get this one is 0 when it's positive 7. So I know I'm going to have a 0 at 0. And at positive 7, I'll go 2, 4, 6, 8, there's 10, so there's 7, and negative 10, 2, 4, 6, 8, negative 10, and there's negative 7. Please label your graph. Now I am going to go and turn off this equal sign, or I'll clear that, I'm done with it. Turn this equal sign on, and zoom 6. And you're going to see these look very vertical, and that's just because I can't see enough up and down. I don't know what it's doing. And then I got to turn the lights on. Thank you for automatic lights. Let's save the environment. I go to the window, and just let's try what happens when we make y like negative 100, if that's enough, and positive 100, and I'll change my scale to be, say, every 20. Do I see enough? I still don't see quite enough, but it's close, so I think I'll go 150. and 50 and 50, and there we go. All right, so just sketch this so that you can see it, clear that you understand it, and I'll make this be 200 and negative 200 because I've definitely shown it a little bit more compact than that. If you wanted to, maybe for extra credit, you could find these points by doing the maximum on your calculator, but that is not essential. All right, last one then is this data one, and make sure I haven't gone over with time. I got a couple minutes. So it says the table shows data with the amount that they're pricing their t-shirt. The cheaper it is, the more they sell, but they don't make much profit. The more expensive it, the fewer they sell, but they can make more profit. But if you don't sell any, it's not going to win. So there's this happy medium point where you might get a maximum. I'm going to delete that. If you go to stat mode and then edit, you'll see I've put in the data already to save time. You go to y equals, and here's where you have to turn plot 1 on. It won't show data if you do not turn it on. If you try to graph functions while plot 1 is on, it's going to try to do data and your equation at the same time, so that's why it should be off normally, unless you're plotting data. I can do zoom 9, and that will fit all my data into the window. Alright, so it looks like it's making sense to me that as I make my t-shirts more expensive, I make more profit, but then if I make them too expensive, I don't sell any at all and I lose money. So I'm trying to find the best possible place up there. So I want to do a quadratic regression. So I do stat, I go over to calc, quad reg is number 5, I hit enter, and I'm going to write that down. So I have, I'll say my profit as in x, p of x is equal to negative 0.17 x squared, and then plus 8.19x. I'm just getting these values right here, a, b, and c, and then minus 57.67. Minus 57.67. Okay? I could go to y equals and type that in. Or if I do variables and then option number 5 and then go over to the equal equation, hit enter, it'll get patched in there. If you have a newer calculator, there's another way to do that. I'll try to show you in a second. But if I go to graph now, it should show the best possible parabola. It looks pretty good. I've got some almost direct hits. That's really the only one that's a little bit off. So now if I want to find that maximum spot, then what I'm going to do is second calc, and find maximum. Yep, that's right. And then I just translate this over so I'm slightly to the left of my maximum. It's a little bit hard if I change the scale, but I'm getting over to the right hand side of my bump. I do enter and enter, and there's the maximum point. Okay, when t-shirts cost $24.02, cost approximately $24. Profit is approximately $40.6 thousand, $40,600. So don't forget to translate it into real money units. Don't tell me you make $40.64. That would be foolish. Alright, so then I would graph this very carefully on that and label it, and you'll see that I will have drawn that out before I post it online. So I hope that helps. Good luck.